Okay, so picking up right where we left off, before we go any further, let's save our work. So go up to File, Save Scene or Save Scene As, and name your scene. I'm going to call this Level 1, and then save it. So what's a scene? Basically, Unity breaks up a game into logical sections. So an example of a scene would be like in an old school side-scrolling games, whether it be a shoot 'em up or a platformer. One level would be one scene. Okay, a title menu could be a scene. For some complicated games, when you go into like when you pause the game and you go into like inventory and skill trees, that could potentially be another scene depending on how complex it is. So there's a lot of use for scenes, but it kind of breaks the game up into these logical units. Another example would be a scene would be, say, an RPG. So a turn-based RPG, a random encounter happens, the battle scene loads up, the monster loads up, and you have the battle. That battle code would be a scene. That battle environment would be a scene. So if there's 10,000 battles in an RPG, you don't have to create 10,000 scenes. You create one scene and use it over and over again. Okay, so we are going to look at moving the character around and having the character destroy the dirt when it touches it, when it's moving in the different directions. So how do we do that? Let's click on our character, click on Add Component, Physics 2D, Rigid Body 2D. This allows for the application of physics. So specifically, we're going to use velocity. We're going to get rid of the gravity scale because we don't need the gravity to work except for when, if you're familiar with Dig Dug, if you dig under a rock and the rock drops, we'll simulate gravity there. But even then, we might not use the gravity scale. We might just apply a vertical velocity. We'll get to that in a minute. I don't want to jump ahead. Okay, so the rigid body allows for the application of velocity. But to apply velocity, we need to take player input. So there's a couple ways you can do this. A lot of games will have multiple types of control. Like you could use the keyboard or you could use the game controller. I'm actually going to use the game controller because let's face it, that's how most people play computer games now. I think people tend to only use the keyboard if it's a really complex game like an MMO or something like that where you have like 10 or 12 different commands, then the keyboard works out really well. But most people, I suspect, use a game controller now. So let's go up to Edit and we'll go to Project Settings and Input. So of course, a game controller is considered input because the player is inputting information. Now, see Input Manager and Axes? If you click on this, okay, so first of all, your game controller needs to be plugged in before you turn on Unity. If you notice, you see horizontal, vertical, and a bunch of other stuff. What you do not see is you do not see left analog and right analog. So does that mean Unity doesn't support a left and right analog stick? No. What it means is that Unity does not see the left and right analog sticks as a left and right analog stick. It actually sees 4 separate axes. So it sees a horizontal axis and it sees a vertical axis. So if you're pressing all the way to the left, that is a -1. If you're not moving at all, it's 0. And if you're pushing all the way to the right, it's +1. And you have a whole range of decimals in between there. Vertical, same thing. If you're pressing up, it's a +1. Pressing down, it's a -1. And there's a whole range of decimals in between there. That's how like if you notice games like where you can make a character walk or walk faster or run just using the analog stick. That's what's happening. It's measuring. It's capturing. Okay, is it being pressed a quarter of the way, 3/4 of the way, all the way? So by taking those various decimals, okay, is it 0.5, 0.75, 1.0? And based on that number, a decision is then made. I don't want to go too far into that because I want you to actually see the code. But the big takeaway from this is don't look for a left and right analog input. It's horizontal and vertical, and then there's a second horizontal and vertical, and you'll see, but you'll need to change the name here to differentiate between them. Okay, so this is the default settings for the game controller. So we've got our character, we have the rigid body, we now need a script. Right-click, create, C#, and we'll call this HeroCon, short for Hero Control. All right. And then just drag and drop HeroCon onto the object. Now we can go into that HeroCon script and start making we can add some code, and now we can start controlling that character. So let's do that. Let's go into HeroCon. And what we're going to do is we're going to have something happen in the update section because we want it to happen every single frame. What we're going to do is we're going to take that horizontal and vertical value, as I said, which ranges between -1 to +1, and we're going to apply it to velocity. So let's do this in a couple of steps. Let's see what velocity looks like. So this script is attached to the hero. So if I do get component, and then I do that rigid body 2D component, I can now make changes to it. So let's do velocity equals new vector2, because it's, as I said, an x and y coordinate. Let's do -3, 0, just so you can see that it's going to move on its own in a negative direction. So let's save that, and then let's run it. Your character now has movement. And I really didn't talk about it too much yet, but every object has an order in layer. And by default, everything's at 0. So you have issues where characters appear behind objects. It's not going to be a problem because when he touches dirt, he's going to destroy it anyways. But that's just so you know why he was occluded, why he was blocked by the other objects. Okay, so you've seen that. Now let's do, say, this is 0, and we'll make this, say, +3. Now he's moving up. So it's that easy to apply velocity. But we really want it to be at 0 unless you're moving the controller. So what we're going to do is we're going to set this, and that speed was kind of fast. So let's do 2 by 2 and just see how that looks. Although in these old games, you'd only move one at a time. You typically couldn't move diagonally. All right, that's a decent speed. I'm not going to worry too much about it. That's a game balance issue. This is just to get you up and running. You can tinker with that as much as you want. All right, but as I said, we don't want this to be moving by default. We want it to not be moving. So that means if we multiply this by a number that starts at 0, increases when you're moving the controller, but then returns back to 0. Well, that's exactly, as I said, that's how how Unity handles input from left and right analog. It automatically, if you're moving the analog stick, there's a value. If you let go of the stick, it reduces to 0. But it's kind of messy to try to put the input here. So what we're going to do is we're going to create a couple of variables to capture the input, and then that way you can just see the variables here and makes it a little bit neater to see, a little cleaner to see. So public, and it's going to be a float since we're going to use decimals, public float x, and we'll call this val, and it will start off as 0. Public float, and again, float allows for decimals, whereas int allows for only whole numbers, but negative numbers as well. So I guess I should say non-decimals. So y val equals 0. So we take this and we now do times xval times yval. We save this. Watch what happens. Not moving. So far, so good. So if we can have this number then change to the velocity, not the velocity, excuse me, the value of the axes, the horizontal or vertical axes, we can then move the character. So it'll go from motionless to moving, and then you let the control go, and it goes back to motionless. So let's take those two variables. Xval equals input dot get axis horizontal. And if you notice this only appeared over here, it's because I spliced the video, because I wanted to remind you that it's literally using this name here. It's using horizontal. Okay. And yval equals input. So again, it's the word input because it's looking for player input. It's axis because Unity doesn't see a controller, it sees an axis. And this one will be vertical. So again, these return ranges from -1 to +1 or 0 if they're not being moved. So this is going to constantly be modified. Now, let's give this a run. It's not moving, so I'm not touching the controller yet. And so now we try moving left or right. And there we go. You now suddenly have movement. Just like that. Okay, so half done. That's the movement. Now we want to be able to destroy the dirt when he touches it. So that's a collision. So what we're going to do is the 3 tile prefabs have a script attached to them. We're going to add some more to that script. So this character, Dig Dug Dude, what we're going to do is when there's a collision, you can actually check for the name of the object that's colliding. That's very common. Like you want to check, is it colliding with a power-up? So a power-up effect would happen. Is it colliding with a bullet? It's going to take damage. Is it colliding with a wall? That's an instant kill. Whatever. You can check the name of what the collisions are. So with him, we added a rigid body, but we did not add a collider. So add component, physics 2D, and we're going to do a polygon collider. That way it's form-fitting. That way this dead space, if something touches him in this dead space, it doesn't instant kill him. That there's a little bit of forgiveness there. So, how does this look? Tile.com is the tilecon, not .con. So tilecon is the name of the script that's attached to the tile. So what we're going to do is we're going to add a new section. So outside of update, so you have to make sure it's not inside of these brackets, but is inside of the bracket for the mono behavior. Okay. So it's void. And this is case sensitive because this is a predetermined routine. If you get even one letter wrong, it thinks you're trying to do something entirely different. So on trigger, as we said, they're triggers, enter 2D, and then it's collider 2D other. And that is, it's colliding with another object. Okay. Before we do any more, whenever you're using collisions, I strongly recommend you test the collision before you put any other code in there. You want to make sure that the collision is working. Okay. So in this case, we're going to see, the thing is, they're kind of overlapping, so collisions are going to happen anyways. So we're going to have to put a little bit of code in first. So if other, and that's not a coincidence that we're using other, it's quite literally referencing this. So if other dot name, so the name of the other equals, as we said, it is dig dug dude. So if that collision is, if that is what it's colliding with, then we want something to happen. Going to destroy game object. Again, this script is attached to the tile, therefore what is going to get destroyed is the tile. So you save that. So yeah, normally, like I said, I try to not do this. I try to immediately test the collision, but in this case, it's kind of hard to not put in pretty much the full code because technically collisions are happening because I believe there's a vertical overlap with the tiles. So let's go ahead and run it again. See if you noticed how the one disappeared below him already. So I want to move him, and that is actually working quite well. Now, as I said, in Dig Dug, he couldn't move. In Dig Dug, he could only move one direction at a time, so that will be part of the game control, where if one is moving, then the other one is automatically set like to 0. That is, if one direction has a value, then the other one is set to 0, so that way he's not moving in two directions. That's a refinement. That's an iterative process, and we don't have to get into that. But the basic is working. The dirt is being deleted, but he's a little bit too big. So what we're going to do is we're actually going to shrink him. So where it says Dig Dug Dude, change this to 0.9. 0.9. Because I noticed things were destroying all around him, and we didn't want that to happen. Let's run it again. Already better. Notice how he's by himself, that the top and bottom didn't get destroyed automatically. So that's much more reasonable. He can still move diagonally. Like I said, we haven't touched that yet. But now it's not ridiculously sensitive. And you could always shrink him a tiny bit more. Like I said, you have to be careful. If you make everything subject to coding for you, you might make something that works great for you, but terrible for the player. Graphics are indeed part of the experience, so you have to be careful about making them too small and that kind of thing. The other thing that you can do, rather than making him smaller, conversely, you can change the box collider on this. So see how the size is 1.24? You could reduce the size of the collider because by default the collider is the size of the image. But if you change the size of the collider, then again you wouldn't have a collision at the outmost level. It would have to go in a little bit. A good example of this would be like the original Pac-Man. Pac-Man didn't lose the moment a ghost brushed up against him. There would actually have to be a decent amount of overlap. So what it is there would be a collider circle dead center to Pac-Man, smaller than the entire image of Pac-Man. So sorry, I kind of went off on a tangent, but I just want you to know there's a couple ways to do this. So that way you don't have to shrink the character anymore and make him look minuscule. You could actually just shrink the collider on the tile itself. So actually, I think that's everything we wanted to accomplish on this one. I'm thinking that I'm going to save the vertical and horizontal control, making them be mutually exclusive is the phrase. So right now you can move diagonally, okay? That kind of breaks what Dig Dug was. So you want them to be mutually exclusive. In other words, you can move in one direction at a time, but not both. So I think that should do it, actually. Yeah, okay, I think that's it for this video. I'll probably get right into the next one.